see, for the ramp response, okay, see, for the ramp response, this is S, and for the ramp response, for this transfer function, I was already discussed for this, the ramp response will be, if your ramp signal is like this, then your ramp response will be like this, and this delay will be tau 1 by omega p. Okay, I already discussed this. So after that, if you want for the whole transfer function, then how you will going to plot? See, it is very easy to plot if you remember for this S by omega p. Okay, I'll second it. I'll discuss second time if you want. You just multiply with s square, then 1 by s you will get outside, and this is h of 0 1 plus s upon omega p, and 1 by s means this is the step response. Means if you see, then it is like step response, like this. And if you integrate, right now this is nothing but an integration. If you integrate this, then you will got what? So, for example, this is the input signal, and this is my step response, then you got this. You just integrate and see, because here see, at infinity this is constant. For the constant means, for the constant, what will be the integration? K into t. So this is nothing but a k into t at the infinity, and for t is equals to 0, this is 0, and for very less t, this is the ramp signal. Means if you integrate the ramp, you will got t square by 2, means u of t, like. Okay, so this is means if you integrate the ramp, then you will get parabolic. So this is look like parabolic. Okay, so, and what will be the delay? 1 by omega p on the tau. This will be the delay for this function. So after that, I want to discuss the total ramp response for this transfer function. Okay, so see, for this, this will be the ramp response. Okay, and for this I'll see. So h of infinity is upon 1 plus s by omega p. So if you want to plot ramp response, then you multiply with the s square. So this is, and this is gone, and this is look like the step response for this transfer function. This whole is look like the step response for this transfer function. Step response for this transfer function. Okay, means for this transfer function, step response, if you plot, then you will get the ramp response for this transfer function. So see, s will gone, then it will become 1, and for this if you plot step response, then it is nothing but the h of infinity, and like this. Means you will get for this, the ramp response will be this. Okay, so I will plot both and add, then see what will be the total response. So okay, let us suppose this is h of infinity. Suppose this is h of infinity. It was, I think, h of infinity upon omega p. This is SSL. Okay, so this is h of infinity. Just a minute. Okay, so see, see, for this, if you actually I want to plot a total ramp response for this transfer function. Okay, for this transfer function. So see, for this transfer function means this first one and this is the second one. So for the first transfer function I plot this and okay, sorry, and the delay, if you see, then delay will be tau, where tau is 1 by omega p. See, and now I already discussed for this transfer function. For this transfer function, the ramp response will be, for this transfer function the ramp response will be the step response for this transfer function. Okay, so step response for this transfer function is h of infinity upon omega p, because the final value for this is h of infinity upon omega p, final value for this. Okay, so this will be the look like, this will look like this. Okay, this is for second. Then if you add both, then you will get what? So see, for the final value, actually, so see here, what was the difference between the input and the first response? Tau. And after that, if you add this, means this is the final value for the second. So if you see at the, if you t, your t tends to infinity, means t very greater, then you see here my input is look like this. This is, my input is look like this, and my first like this, and I want to add this constant value, this constant value. And what is the constant value? H of infinity by omega p. So if you add this constant value to this plot, so let us suppose this plot is nothing but t, then if you add this plot to this, so it will become t plus h of infinity by omega p. Means this shift upward, you shift upward. So see, if you, this is the point 1, then if you shift upward, then to shift here, so this will look like this. Means this delay will reduce. See, this delay will reduce by how much? This means this difference will be h of infinity by omega p. So this delay will reduce by this h of infinity by omega p. So now my final plot will be, my final plot means final output or final ramp response will be with a, this is, let us suppose my input, this was my input, and my final output will be, now my delay is reduced, and minus by h of infinity upon omega means 1 upon omega means tau. So if you common the tau, then 1 minus h of infinity. So now this delay become less. Either you write like this, and either you write like 1 by, this is tau, 1 minus h of infinity is how much? H of infinity is from here omega p by omega z, omega p upon omega z, h of 0, and this, right, omega p, then, and you know tau is equals to 1 by omega p. So if you write omega p, then it will become 1 upon omega p minus 1 by omega z, h of 0. Okay, so this will be my final plot for the whole circuit. If anything wrong in this calculation, then please correct me. Okay, thank you.